In this video, we're going to look at example 3, part B, where we're graphing transformations of cubic parent functions. So how to transform graphs compared to the graph of the parent function. We're talking cubics, so our parent function, actually let me write that in red since it's in red on the graph. The parent function, remember, is just x cubed. Okay, and we're talking about the transformations here, and we pretty much have all the information here. Everything has been provided for us already. We have the function and we have the graph. Usually you'll be given one or the other, and you'll either have the graph and you'll need to determine the function, or you'll have the function and you need to determine the graph. But in this case, everything's been provided for us. So we're just going to talk about how these numbers and the function affects what the graph is going to look like. So first thing we're talking about in terms of h of x is that we have 5 times x minus 2 cubed. So I'm just going to rewrite this. We talked about the parent function down here, and let's look at each individual piece. So I'm going to start with the order is not going to be too important, but I'm just going to start with the 5. I'm just going to go left to right. Hopefully from previous lessons, they were a while ago, but we want to remember that since that 5 is greater than 1, multiplying by 5, I'm going to write this all out. So multiplying by 5 is going to stretch our graph. All right, and it's going to stretch it, we'll say, vertically. If you look at the original, this red one here, you can see that that new bluer one, this piece here, does look like it's been stretched. It's been pulled from the top and the bottom. It's kind of becoming more narrow. So what we're doing is we're stretching. Right, don't overthink that. That's all there is to it. Now we're going to look at this -2 or subtracting 2. So by subtracting 2, again, this should be kind of review, but by subtracting by 2, we're going to shift the parent function right 2 units. And if we look at this origin spot here, and kind of here where we're going to be changing directions, we're going over 2 places. All right, so that's our shift right 2. Again, hopefully most of this is review for us. So by subtracting 2, we're moving to the right. You want to remember that that number on the inside is the opposite. So if you're subtracting, you're going right. If you're adding, you would be going left. And then finally, let's look at this +4. So by adding 4, we're going to shift the parent function up 4 units. And we kind of showed that already where we had that origin. It's going right 2 and then up 4 places. Now maybe I specifically kind of left this out. You may remember that this looks kind of like our A, H, and K. Right? In the past, we were working with some quadratics. Now we're looking at, in this case, a cubic function. The rules still apply. All right, so you still can be stretching or compressing your graph vertically. Your shift, that H value, is going to determine the shift left and right. Remember that one is the opposite. And then your K value determines your vertical shift up and down. And that one's the easiest one. If you're adding, you move up. If you're subtracting, you move down. So do keep this in mind. We're looking at A, H, and K. So like I've mentioned a couple times already, hopefully you do remember this from previous lessons and you remember what each of those values do. But this is a nice quick little review and to show you that those rules apply to both quadratics and the cubics.